Hi, this is Paul with Tweaktown. We're here at Flash Memory Summit 2013. We're sitting down with John Scaramuzzo from Smart Storage Systems. And these guys make waves. It's the only thing they do. So, I mean, it seems like, one great thing that we're seeing here at the show, and it's a great hit. I see a lot of traffic over at their booth, is the new ULLtra DIMM product that you guys have developed. It's almost intuitive, it seems, but it seems like, why hasn't anybody done this before? And can you give us a little bit of an overview of what ULLtra DIMM is and how it operates?
Well, absolutely. I completely agree with you. Why hasn't someone done it? But if you think about it, flash-based storage has really only existed for half a dozen years. I mean, it goes back many, many years, but really,
it's a viable solution.
Viable solution. It's only been a few years, and we saw a very quick adoption of PCIe-based storage cards. And the basic reason is, once you get past the rotating storage device, you eliminate the rotational latency of a hard drive. Your next bottleneck becomes the interface.
Absolutely. And
what people realized very quickly was that if you connected flash storage directly to the PCIe bus, you eliminate the latencies from the HBAs that you had to connect your hard drives to, right? So whether it's a SAS or a SATA hard drive, you had a SAS or SATA HBA, that created latency, that created variation. You never even saw it because it took so long for the disk to come around, it swamped out those latencies.
Absolutely.
So once we started connecting flash to storage interfaces, those latencies became important. PCIe was a way to eliminate the hard drive-based latencies, the SAS HBAs. And what's cool about memory-based storage is it eliminates all the latencies. So you basically connect directly to the memory bus, which goes directly to the processor.
And a big thing too with PCIe, and I see a lot of guys talking about it when they're talking about motivators for deploying those type of solutions, is ease. I mean, you're going from 50 hard drives or even 10 or 15 SSDs, and you've got backplanes, and you've got expanders, and you have HBAs and SAS cards. So they're like, hey, instead of running all the power and the data, we just slip in a solution, less than 25 watts, addresses our concerns with PCIe, but with putting that on the RAM bus is an even smaller, denser package, and it's just as simple.
Well, yeah, it's just as simple, and I think there's another important point. Not only is it you eliminate the PCIe bus contention, because there's latency there too. You've got PCI storage devices, you've got your HBAs connected to the bus, you've got your graphics card,
networking equipment.
All of that stuff is connected to the PCIe bus, and that creates conflicts and contention, and that creates latency and latency variation. So you bypass all of that. But the other thing with the DIMM-based or memory-based storage is there's a lot of DIMM slots out there. And it allows you to have smaller chunks of storage, smaller chunks of performance. But when you put them together, it scales linearly.
So there's no we're not seeing the curve of watching our latency go higher.
No, every time you add a device, you get linearly scaled IOPS and the same response time.
Because each RAM slot has basically its own channel.
Correct.
It's to one core of the CPU, correct?
Absolutely.
So it's just a straight shot. I mean, and that is the goal, is to get flash as close to the processor as possible, because sometimes putting it at the end of a SAN or on a network at the end of a long tube, that's kind of a self-defeating.
Yeah, and there's no other form of storage that scales this way. Because every time you add a device, whether it's to the PCIe bus itself or to one of the HBAs, you add contention, you slow it down, you have a pipe, limited bandwidth at the end of that aggregating device, and so you get diminishing returns. This is the only interconnect that will allow storage performance to scale linearly.
And this allows it to be addressed as both block or RAM.
And that's the flexibility and the exciting part as well. You can take all of your traditional applications and you can connect them essentially to the memory bus and get all the advantages of the latency variation and performance of the memory bus, and you can still use it as a block storage device, or you can start dreaming up how to expand your memory from a few gigabytes to a few terabytes.
Absolutely, we see a lot of the big guys, the big players are redefining storage and how it's addressed. They're using their own operating systems, and so for them, a solution like this can be really attractive because they don't have to wait for the Microsofts of the world to meet their needs. They can create their own. So it's an exciting product.
I think we're excited to announce it, and we're excited excited to get it out there to the application guys and to the designers and innovators, because I know we talk next year this time, we'll be talking about applications we didn't even dream about at this point in time.
And the final important key to all of this, of course, is going to be endurance. And endurance is your bread and butter at smart storage. I mean, the Guardian technology gives almost unmatched endurance from MLC. So can we expect the same type of endurance features in these new products from
Exactly the same. All of this stuff is good, but it's not really good if it's too expensive.
It's got to be affordable.
It's got to be affordable, and that's the thing that Guardian Technology Platform brings to the table here. It allows us to build these devices with consumer-grade flash and get the type of endurance out of it that will work in the enterprise applications that we're talking about. And so now you have performance, speed, response time, storage density, and cost. It's a pretty good package.
It is. It's great. It's revolutionary, and there is a lot of buzz here about it. Their booth has got a lot of traffic over there. We can't even get in there yet.
But we're very excited about it.
We are excited about it as well. Thanks for stopping by, John. We appreciate it. Thank you.
Appreciate it.